Welcome back to another AP Pre-Calculus video. Today we'll be going over topic 3.10, worksheet A. This is part 1, and then part 2 will be worksheet B. So for 3.10, I'll only be working on the odd questions, but I will be providing the answers to the even questions too. So let's go ahead and get started. So from problem 1 to 6, find all solutions on interval x is greater than or equal to 0, but is also less than 2 pi. So that means that we just want the answer to x. Down here it says find all solutions. That means whatever answer we have, we want to add the period, so plus 2 pi k, or in tangent's case, the period is pi, so it'd be plus pi k. Let's go ahead and get started with number 1. So sine of what is equal to this. So in this corner, I'm going to draw like a small little unit circle here. I think it's the best way to know these 3 values in quadrant 1. It's really small to write it, but I'm going to try to write it here. It looks something like this. And the first one's pi over 3, middle is pi over 4, and this one's pi over 6. And from that, you can kind of know everything else. And I like to also remember that the first quadrant, so the thing to memorize, all students take calculus. That will help you memorize what is positive and negative. So all students take calculus, what the letter. So all over here is positive. All students. So the letter S, sine is positive here, tangent's positive here, and then cosine's positive here. So that will help us here. So we see sine of what is equal to square root of 2 over 2. We see square root of 2 over 2 for sine is right here, which is pi over 4. But we also know that where else is sine positive, so all students. So sine is also positive. Quadrant 2, which will be, that means that it'll be another one that has something over 4. So we know it's quadrant 1 and quadrant 2. So we know the quadrant 1 already is pi over 4. But what's the quadrant 2? So we can do the rule of 12. Remember, it starts at 0 here, and each major line, each of them is like 6, so this is 0, 6, 12, 18. That's how I quickly remember. But because this is 6 and then 6, 7, 8, 9. So it would be 9. 1, 2, 3. Those are 3 main lines, right? But we need to count the line in between. So 6, 7, 8, 9. That right there is the middle line, which is a number over 4. So 9 pi over 4, 9 pi over 12, but that simplifies to 3 pi over 4. So the answer to 1 is that and that. Here's the answer to number 2. Alright, number 3, we have cosine is equal to 0. So, cosine is x, so 0, and then a number there. So where is cosine 0? We know it could be 0, 1, or 0, negative 1. So we see 0, 1 is here, and 0, negative 1 is here. So that would be pi over 2, and then it's 3 pi over 2. You kind of just have to memorize. I like to memorize quadrant 1 and then the vertical and horizontal lines. Remember that, and then the rest is will be straightforward to get to. So answer to number 4. This is quadrant 2 and quadrant. So number 5, where do we have sine negative? From our first problem, we know that a quadrant 1 and 2 is positive, so that means quadrant 3 and 4 is negative. Negative 1/2, we know sine is negative at pi over 6, sine is 1/2 at pi over 6, so then it would be this line right here, the 6's. I know this is 7 pi over 6, and this is 11 pi over 6, so. Alright, and then the answer to number 6 is right. It's quadrant 1 and quadrant 3, and that will be the pi over 3's. Alright, and that was part 1. Now this part, we're basically doing the same thing, but find all solutions. So that means we have to add plus period k to our answer. So let's say for this one, I'm going to draw another one here. Alright, so I know that sine is this at 3's, something over 3, and positive at quadrant 1 and 2, so pi over 3. So I already know pi over 3 is one of the answers. And now I want to add plus, what's the period of sines? It's 2 pi, and then k for any number because it's all solutions. And now the other one will be the positive here, which, remember, the trick is that this is 6, 6, 7. You need to count like an invisible line here. 6, 7, 8. So it's 8 pi over 12. You can also simplify to 2 pi over 3. So 2 pi over 3. And then you write the same thing. And then that's the answer there. Now the answer to number 8. Alright, now number 9, we just have tangent is equal to 1. So whenever tangent is equal to 1, I know that it's this one right here. This one that's being divided or multiplied by, or divided, yeah. Because you divide y, it's y over x is what tangent is. And when I divide these two, I know I'm getting 1 because they are the same number, and when you divide, you multiply the reciprocal of the other one, and so that basically gives you 1, right? So where's tangent positive? All students take calculus, so quadrant 1 and quadrant 3. I know quadrant 1 is pi over 4, and because the period of tangent it's only pi, we write pi k. The period of cosine and sine is 2 pi. That's why we write 2 pi. But for tangent, we have to write pi because it has pi as a period. Now the other one, the other positive is, I know it has 4 as a denominator, and the middle one here, so I know this is 12, 13, 14, 15, 16. So right here, so 12, 13, 14, 15, 15 pi over 12. 15 pi over 12, you can simplify that, divide both by 3. That's 5 pi over 4, plus the same thing. And that is our answer there. So the answer to number 10, this right here, there's only one coordinate where sine is -1. It's that's that coordinate right there, which is 3 pi over 2. Alright, and now 11. We have cosine as a negative. We know cosine is square root of 3 over 2 at denominators of 6. But where's cosine negative? All students take calculus. So cosine is negative quadrant 2 and 3. And we have denominators of 6, so this one right here. So I know this 12, 11, 10. So 10 pi over 2, or 10 pi over 12 also simplifies to 5 pi over 6. And then the other one in quadrant 3 is this one right here, which is 7 pi over 6 plus 2 pi k. Now the answer to number 12 is we have this right here. That one would be a coordinate that looks like this here. But because it's negative, one of them has to be negative. If both of them are negative, then it would become positive. But one of them is negative. So one coordinate with this would be negative. The other coordinate, this one would be negative. So, yeah. So now, for problems 13 to 14, find all solutions on the interval of this. Okay, so we're basically doing the same thing as part 1, but we're actually, so we need to isolate our trig. So we want to isolate it. That gives me -1. Now we divide by 2. So cosine of x is equal to -1/2. And let me go back to here, right here. I know cosine 1/2 is with a denominator of 3, whereas cosine negative, quadrant 2 and 3. So we have 8 pi over 12. 8 pi over 12 was 2 pi over 3. And this one right here, which was 4 pi over 3. So 2 pi over 3 and 4 pi over 3. And because we're solving for an interval here, we don't add plus 2 pi k. So that's our answer for 13. Now 14, isolate that. So we can divide that, 2 divided by 4 takes away the 2, and this becomes a 2, so make sure it's still negative. Alright, so where is sine? Where does sine have square root of 3 over 2? That would be the denominators of 3. And where is sine negative? Negative at quadrant 3 and quadrant 4. We know at the denominator of 3 at quadrant 3, we just did it, that's 4 pi over 3, so I know one of them is 4 pi over 3. And then for quadrant 4, we have it right here, which is 18, 19, 20. 20 pi over 12, which can be simplified to 5 pi over 3. So that's our answer. So here comes the harder questions. I already put down the even questions for you guys, so you guys can see the work that I did. And number 18 and 20 are a bit harder. When I get there though, I will explain just a bit. So yeah, so let's get started. Number 15. So it's telling me that I want to find the points of intersection of f and g, so I want them to equal to each other. So I'm going to make them equal to each other, their entire equation. And now I want to solve for the trig function, or for x, by isolating cosine of x. And look, it's saying this interval here, so that means I'm not solving for all solutions. I don't want to add the 2 pi k or pi k. So just making sure you guys don't do that. So let's go ahead and isolate this. That would give me cosine x is equal to 0. Cosine of x 0. I know it could look like that or look like that. And so I know the places that are that are it's literally the y-axis. That's there, it's the y-axis. This right here is pi over 2, and down here is 3 pi over 2, so that's the answer. That's easy there. This right here is basically the same thing, but except and then you have to do sine of x is equal to -1/2. Now number 17, points of intersection. So let's get that equal to each other. And then isolate the tangent. That would be 1. Alright, so tangent of x is equal to 1 over square root of 3. So I know, looking back to right here, which one, it's either, so it would either be this or this. That would give me 1 over square root of 3. So let's check it. So when I divide these two, y over x, square root of 3 over 2, multiply by the reciprocal is 2 over 1. That means that it would equal 2 times the square root of 3 over 2, and I can cancel the 2, so that would just be square root of 3. So this one right here would give me 1 over square root of 3, because 1/2 times 2 over square root of 3, that means that the square root of 3 is at the bottom, and I can cancel out the 2's. It would be 1 over square root of 3. Alright, so that's a denominator of 6. And so positive, so all students take calculus. That is quadrant 1 and quadrant 3 of the denominator 6. So I know that's pi over 6, and then quadrant 3, that would be 7 pi over 6. Alright, so here, number 18 here, you're basically solving for it. Once you reach this cosine to the power of 2 times x, you can basically square root the entire cosine to get rid of that to the power of 2, and then square root of this, right? Also negative 2 divided by -4, that just became a positive 2 over 4. So you can square root both numbers, square root of 2 and square root of 4. Square root of 4 would become 2. Square root of 2, you can't do that, so it just stays as square root of 2. Every time you square root something when you're solving, you gotta add the plus or minus. So cosine of x can equal to negative square root of 2 over 2, or positive square root of 2 over 2. And then that was literally every single quadrant, and then it was just all the values that have a denominator of 4, because the denominator of 4 has a cosine of that value. Alright, so number 19. So we have the function h is equal to that. What are the zeros of h on interval that? whenever you're solving for 0, you just equal the equation to 0. So you go to 0, and then you solve from there. So doing this, I can see both terms, they have sine of x, so I can factor sine of x out. Plus 1 is equal to 0, and that right there we got two separate terms right there. So this side is equal to sine of x is equal to 0, and then the other side, you want to minus 1, get rid of that 1, divide by 2, so that's negative 1/2. This side is sine of x is equal to negative 1/2. So sine of x is equal to 0. That would be this coordinate and this coordinate right here. And I know that this right here is pi, and then this right here is 2 pi or 0. But if we look back at the interval here, we cannot have 2 pi because it's not equal to. It does have an equal to for 0, so it's not 2 pi. And so it's just 0. So I already know two of our answers is pi and 0. Now let's look on this side. Sine is negative at quadrant 3 and quadrant 4. And if we look back at the thingy, 1/2, we have sine 1/2 at denominator 6. So we want denominator 6 at quadrant 3 and quadrant 4. That would be 7 pi over 6 and 11 pi over 6. So 7 pi over 6 and 11 pi over 6. Alright, and now this one right here, if you look, we moved everything to one side and equal it to 0. Then I got it to look like this right here. That reminded me of like a quadratic.
Oh, when we used to do quadratics.
They were so much simpler, weren't they? But yeah, because it's a quadratic, we were able to split it like this, and then find out what multiplies to -2 and adds 2 to 1. Right there would be 1, right? Would add to -1. That would be -2 plus 1. That gave me -1, and -2 times 1 gives me -2. And then I split those two off. They were separate now. Cosine of theta is equal to 2, and cosine of theta is equal to -1. Cosine of theta equal to 2 is nowhere on the unit circle, so that was nothing. But -1, that gave me pi, so it was just pi. These last three problems, we're just solving for the points of intersections. So I went ahead and already equaled them to each other. So now we just need to solve for the sine of x. So I'm gonna move all the stuff to one side. So you go to 0. Then I can see they both contain a sine of x, so I can factor that out. Now they're separate terms, and then so they each need to equal to 0, and then solve for that. So this side is equal to 0. This side, however, is minus square root of 2, negative square root of 2 divided by 2. So I know this side right here would be these two coordinates, which is pi over 2, but you can't do pi over 2, so 0 and pi. So I already know that I have x is equal to 0 and pi. And then on this side right here, we have that one, which I know is a denominator of 4, and it's negative. Sine is negative at quadrant 3 and quadrant 4. So pi something over 4. And if you can look back at the one you made before, or if we do a new one, I know 4. So these two right here, I know this is I'm gonna add 2 more lines there so you can count. So this is 12, 13, 14, 15. So 15 pi over 12, which also simplifies to 5 pi over 4. And then this one right here, 18, 19, 20, 21, 21 all pi over 12. That simplifies to 7 pi over 4. So you divide both of them by whatever gets the denominator to 4, because I know the denominator is 4. So now I can add those to the answer. That would be the answer for number 21. Now number 22 looks like a lot. Yeah. So I set them equal to each other. Then I add them all to one side, and I saw that cosine of x is I can factor that out, and So now I had these two, and then I solved them each. They're both equal to 0. This one gave me cosine of x is equal to 0, and then those are the two values based on those two coordinates. Then here, I added 3 and divided by 4. I needed to get rid of that to the power of 2, so I square rooted it. To get rid of it, square root of this would just be square root of 3 over square root of 4, but square root of 4 is also 2. Right here, right? But because we square rooted it, it's also plus or minus. So negative square root of 3 over 2 and positive square root of 3 over 2, which gives me to this coordinate right here, the cosine. This one right here is negative or positive, then it would give me like, yeah, it's just every single coordinate that has square root of 3 over 2 on the unit circle, because it's positive or negative. And so it gave me to every single number that had, or every single value that had a denominator of 6. Because if we remember back to quadrant 1, this quadrant right here is just pi over 6. And then from there we can get all that. So now number 23, I set it equal to already because it's points of intersection. And so I can see I can move that to the other side and equal to 0. And I can see I can factor out tangent of x, so I'm gonna do that. And now I can solve for each of them. So tangent of x is equal to 0, and then on this side is tangent of x is equal to negative 1. So I know 0. To get 0, it's 0 divided by a number, not a number divided by 0. That would be undefined. So that means it's gotta be these two coordinates. That would give me 0 and pi. Remember, we cannot do 2 pi. And then on this side, I have negative 1. To get 1, the coordinate is this, right? But because it's negative, either this one is negative or this one is negative. If both of them are negative, then it will become a positive 1. So only one of them can be negative. And where's tangent negative? All students take calculus. Tangent's negative at quadrant 2 and quadrant 4. And so if we draw a unit circle, quadrant 3, or quadrant 2 and quadrant 4, I know this right here is a denominator of 4. So that's pi over 4. So the middle line, right? So if we add like the other lines, right? So 6, 7, 8, 9 pi over 12. And then this one is 18, 19, 20, 21 pi over 12. And then we can simplify that. 9 pi over 12 can be simplified to 3 pi over 4. That has a denominator of 4, so that looks good. And then 21 pi over 12 can be simplified to 7 pi over 4. It also has a denominator of 4. So our answer is, and that is our answer. And that was part 1 of 3.10, and that was a lot. So yeah, get ready for part 2, I guess. But thank you so much for watching, and hopefully that helped.